Okay, welcome into this lesson on converting fractions to decimals. This lesson focuses on famous fractions and using the bus stop method. Okay, so first example, okay, is 1/5. Now, what you must remember is that this line here separates the 1 and the 5. Remember, that's another way of writing divide. So this just means 1 divided by 5. And to do this, you can use the bus stop method, okay, like this. It means remember how many 5s are in 1, like this. Well, how many 5s are in 1 is 0. Remember, and there's a remainder 1. That means it's going to be a decimal. So I put a decimal point down and I add some more zeros. I always add 5 zeros. You can add 2, 3, 4 if you want. It's up to you, okay? I add 5 zeros and the remainder was 1. And then how many 5s are in 10 is 2. Exactly 2. That's why 1/5 as a decimal is 0.2. Okay, I mean, you may know some of these already, but I'm trying to show you why it works here. Okay, 1/4 means 1 divided by 4. So if you get the bus stop on the go, how many 4s are in 1? Well, it's none. Again, remainder 1. Here you go. Remainder 1. How many 4s are in 10 is 2. Remainder 2. How many 4s are in 20? Exactly 5. Forgot the point, sorry. That's why it's 0.25. Again, you might already know that 3/4 is 0.75. You should do. But again, this is why it works here, okay? It means how many 4s are in 3? Well, how many 4s are in 3? 0. Okay, and carry the 3 over. Don't forget your point this time. How many 4s are in 30? 7, remainder 2. And how many 4s are in 20? Exactly 5. That's why it's 0.75. Okay, and then a couple more. 1/3 is a bit more badly behaved. 1 divided by 3. So 3's into 1. Well, again, how many 3's are in 1? None. Okay, carry the 1 over. How many 3's are in 10? Is 3. Remainder 1. How many 3's are in 10? 3 remainder 1. And you can see what's going to happen here. This is going to go on forever. This pattern's never going to stop. It's going to go 3 remainder 1, 3 remainder 1, forever and ever and ever. This decimal never stops. Okay, so obviously we don't want to write it out forever because we haven't got time or the paper. So the way to write this one is 0.3, and the 3 repeats or recurs forever. So you put a dot on top of the 3, and this means 0.3 forever and ever and ever. It's called a recurring decimal. These ones on the left-hand side are called terminating decimals because they stop. Okay. This one here, okay, again, will be a recurring decimal because the thirds are normally quite nasty here, okay? So here we go, look. How many 3's are in 2? Well, again, look, and it's none. This time remainder 2. So put the 2 down. How many 3's are in 20? 6 remainder 2. How many 3's are in 20? 6 remainder 2. And see, it's going to go on forever. 6 remainder 2 forever. So this now, okay, is going to be 0. And this time the 6 recurs forever. It's 0.6 recurring. Okay, and this last one, if you thought the thirds were nasty, they are nothing compared to the sevenths. Okay, A, because the 7 times table is harder, but the 7s are particularly badly behaved. So how many 7s are there in 4? Okay, well, again, there's none. This time remainder 4, and this is going to be quite nasty. How many 7s are in 40? Is 5. Remainder 5. 7's in 50 is 7. Remainder 1. How many 7s are in 10? 1. Remainder 3. See, it's still going. There's no repetition here. 7's in 20 in 30 is again 4. Remainder 2, and there's still no repeat. And look, how many 7s are in 20 is 2, and there's yet more remainders. So I have to add another naught here. How many 7s are in 20 is 2. Okay, and then the remainder is 6. And how many 7s are in 60 is 8, remainder 4. Now I think I'm running out of space. Oh, I can just about cheat here. Look, all right, phew, I was lucky. I can go off the screen. I got to go off the screen. Remainder 4. Now, luckily, how many 7s are in 40? 5. Remainder 5. And you can see what's going to happen now. See? This block is going to start repeating again because, see, I've hit this remainder. See, once you get the same remainder, see, I've got a 4 here and a 4 here. We know the whole pattern is going to repeat. So this one is best written like this: 0.571428, and the 571428 all recur again and again. You just put a dot on the first number and a dot on the second number. You don't put a dot on all the numbers. That would look incredibly scruffy. Okay, there we go. The 7s are awful. Okay, but for the main task now, okay, there's plenty here for you to have a go at. All right, the first few are easy, and then there are some recurring ones in here as well. So have a go at the main task, and then come back when you're ready for the answers, okay? Okay, welcome back. Here are the answers, all right? See, I had to change my pen size for the 7ths because they are so nasty. That does say 0.7 there, okay? It just looks terrible, all right? You should spot some nice patterns, like the 9ths recur with a lovely pattern. The 7ths are a pain, and the 12ths aren't actually too bad, okay? So make sure you mark what you've done, all right? And after that, then you should be okay. So thank you very much.